This is the fourth and final video on section 5.1, functions and level curves. So here we're going to look at example 121. So for parts A and B, we have the function f of x, y, z is x squared plus y squared plus z squared. Now this is a function of three variables. That means this graph is four-dimensional. So we can't sketch this graph. In fact, it's even hard to even imagine what a four-dimensional object looks like. But the graph of this function is four-dimensional. So when we start to look at level things, we don't call them level curves anymore, we call them level surfaces. Because if we had our fourth variable, let's call it w, and we're going to hold that w fixed, and we're going to look at the level thing, and that thing is a surface instead of a curve. So for part A, we're taking our fourth variable and we're holding it constant to be 1. And we're looking at the cross section. The cross section then is x squared plus y squared plus z squared is equal to 1, which is the unit sphere. So it's just the sphere centered at the origin, which is 0, 0, 0 of radius 1. For part B, we do something similar, except we take that fourth variable and we hold it constant equal to 9. And so this is just the sphere centered at the origin of radius 3. For the other two parts, for parts C and D, our function is f of x, y, z is x plus y minus z. Again, this is a function of three variables, so its graph is four-dimensional. So again, it's hard to imagine a four-dimensional object, let alone draw one. So what we're going to do is we're going to look at the level object, and we're going to call the level object, it's a level surface instead of a curve. So we're going to hold our fourth variable, call it w, equal to 1, and we have x plus y minus z equal to 1. Well, that's a plane with normal vector 1, 1, negative 1, and passing through a point, well, find a point that satisfies this equation. And so you just have a plane with normal vector 1, 1, negative 1. For x plus y minus z equal to 4, it's similar. We have a plane with normal vector 1, 1, negative 1. They're different planes. So the plane in C and the plane in D are different. They're parallel because they have the same normal vector, but they're different planes. And again, pick a point that satisfies this. So 4, 0, 0, for example. So this is a plane that passes through the point 4, 0, 0 with normal vector 1, 1, negative 1. So these two planes are parallel, but they're different planes because we've taken our cross section at different places.